Community. In this video, we're going to introduce the sensors Robot Pew is using. All the sensors comes from microbit and also comes from external sensor like a sonar. This is how Robot Pew is doing observations on a wall. Then, based on the sensor signals, Robot Pew will think and takes actions. So, for example, there's a gyroscope in Robot Pew's head in the microbit, and when you tilt Robot Pew, and you can see Robot Pew will try to rotate his foot to do a counterbalance, and when you clap it, and Robot Pew will respond to your clap and try to look for you. And this is order, as you can see. This is a microbit inside Robot Pew's head. There's all the gyroscope, temperature sensor. Let's take a look at it. This is, as you can see, all the sensors are labeled at here. So you can see there's microphones right here, and the speakers here, and the accelerometer is here, and compass is here. So yeah, so and in this chapter, let's introduce the details about how to read the sensor inputs, and then take and how to use all the sensors. As you can see here, I have a table that lists all the sensors Robot Pew is using. The first one is microphone. You can use microphone to do recording about your voice. You can use that to, if your Robot Pew is a security guy, you can use the sound level to do the security alert. Also, it's also useful for Robot Pew to detect music beats, such that Robot Pew can fit into dance tempos and make fit into then do the nice dance movements that fit into the music patterns, music tempos. The second, and you can click here to get used to all the features of the Robot Pews has, and also examples can be seen from here as well. So the second one, it is accelerometer. You use in all, it will return the acceleration at XYZ direction, but with simple calculations, you can use accelerometer to capture the gesture control. For example, face up, face down, tilt left, tilt right, something like that. So, and you also can use the vibration detections for the security purpose as a security camera. The next one is temperature. So you can use that to do hazard avoidance and also monitor room temperature. Next one is compass. Robot Pew comes with it can detect the magnetic field, and mainly used for robot navigation. And the next sensor, even though it's for radio antenna, so it's useful. It's extremely useful, of course, for communication, for radio control, but it's really also useful to find robot friends. So if two robots in close by and they can detect the radio signals, then based on the strength of the radio signal, those robots can estimate how far away those robots, and they can walk around, try to walk closer to each other and find each other. Next level is a light sensor. Basically, that's the surface. That's building LED in a microbit. You can use that to trigger alarms or trigger events. And also, it has a touch sensor. Microbit pins, it's touchable. So For example, all the pin here, the logo button here is a touchable. When you touch it, then there's it can detect the signal and trigger something. And a couple of pins also touchable. You can use that to implement really cool functions. Say you can trigger robot pulse emotion, or use that to find some useful trigger to find people around, something like that. Okay, the next one is a sonar sensor that's live in the basically there's two googly eyes in the robot pulse chest. It can use to detect the object in front of it. Is designed a specific angle such that whenever there is object in front of it, the robotic pupil can do auto navigation and try to avoid the obstacles. Of course, for the joystick, the robot pupil it's got joysticks. There's also a sensor. So we use the gamepad expansion ball to detect the joystick signals, so such that you can do really precise movements of robot pupil. Yeah. So then we list all the example here on the right side of here. So if you want to understand what's the examples, you can just click here to see and understand how each sensor works. Okay, so and here we have some example code. How do we link each buttons to the event? And in this chapter, we're mainly going to explain the gamepad joystick programs. You can reach it by edit. Click this edit button and click this edit again, and that's basically a gamepad program. For example, see, we map each pin to an event, and it is the joystick program. It capture the joystick signal in XY and map into the robot speed and turning direction control. It's detect the microbits rotation and send out the pitch and roll signal, and such that when it can map the gamepad directions to the robot pupil's head movements. For example, if you push joystick and make a robot pupil work, then in the working mode you can see when I lift up the gamepad, robot pupil's head also move up. If I turn left and right of the gamepad controller, robot pupil's head also move left and right. Yeah, so this is how we capture it. And see at here, if we put some loud noise here, so it will trigger some event to make robot pupil like do something. And see, this is a logo button press. When you press the logo button, we're going to find out the orientation, the pitch and roll of the gamepad controller. Then use the roll and pitch to search for all the words the robot pupil can talk. So then you use a pitch and roll to find out which word robot pupil going to talk. Then when you press the logo button, and robot pupil going to pick the word you selected by pitch and roll and say it out. See, that's a put command. And overall, take a look at the gamepad program and try to understand what we are doing here and how do we control the robot pupil.